So I created this question as a challenge to all the pre-calculus students. First, it might look like a simple concept question because we just have a polynomial function p of x and we just have to get p of 6. So we can just plug in 6 into all the x's and then do the work, right? But you know the catch, we will not be using a calculator for this. So, do you still want to plug in 6 into this x, maybe? 6 to the 5th power is what? Okay, multiply by 20. Okay, maybe do the next one. 6 to the 4th power is what? Multiply by negative 399 is what? And then do the rest. I don't think so, right? So, what's the idea behind this question though? Well, do you really know how polynomials work? Here, we can borrow two concepts from polynomials. One is the remainder theorem. Two is the synthetic division. Let me demonstrate how it works and I will explain why it works. First, I'm just going to do the synthetic division. So I'm going to set it up right here. And we need a really big one because all the numbers, all that. So I'm going to write down the coefficients. 20 x to the 5th, negative 399 x to the 4th, and then 2980 x to the 3rd power, and then negative 9850 x to the 2nd power, and then 12,000, and then 625. Now, everything is present because we have all the exponents, so we don't need to add any zeros. Next, if you want to do p of 6, just put a 6 right here. And then do the work. Bring down the 20. And then let's do 6 times 20, which is 120. And I will also not be using a calculator. So this is like, we are adding them up, right? So it's like positive and negative together. So that will be 9, and that will be a negative result. This and that will be 7. This and that will be 2, so negative 279, and then do the rest. 6 times this, let's see, I will do 6 times 9, which is 54. And then 6 times 7 is 42. 2 plus 5 is 7, with a little 4. And then 2 times 6 is 12, plus the 4, so altogether 16. And that's negative. Now let's combine them. Positive minus, so it's just subtract. So this is like 10. So borrow the 10. 10 minus 4 is 6. So now this is a 7. 7 minus 7 is 0. And then 9 minus 6 is 3. 2 minus 1 is 1. And then continue. 6 times this, put it here, which is 36. And then 18. And then 6 times 1, 6 plus 1 is 7. Negative, positive, so again, kind of subtract. So I'm going to do this subtract that, but it's going to be a negative result. So it will be like the deal 10, that will be a 4, and then that will be 4. 4 minus 3 is 1, 8 minus 8 is 0, 9 minus 7 is 2. Yeah. Okay, this one was fun earlier, by the way. And then just continue, negative 2014. I should have done this like 11 years ago. But anyways, so multiply, we will have a negative result. And then 6 times 4 is 4 with 2. 6 times 1 is 6, and then plus that's 8. And then 0, and then 6 times 2 is 12. Combine them. Very nice. We get a negative 84. Finally, take this times that, put it here. 6 times 4 is 24. Oops, wrong color. 6 times 4 is 24. And then 6 times 8 is 48, plus the 2 is 50. And then we have a negative. Now, combine them. That will give us 1. This and that will give us 2. And then 6 minus 5 is equal to 1. And this right here is the remainder. And in fact, this is the answer for P of 6. It's 121. And we are done. Seriously, right? I guarantee you that is the answer. Now, let's talk about why this works. In order for me to do so, I will have to use a blue pen. So here's the idea. When we run through the synthetic division, when we put a 6 right here, we are taking this polynomial and divide it by x minus 6. So I'm going to just write this down. P of 6 is equal to, if it's a 6, then we are divided by the factor x minus 6. Okay, and then these right here will be the quotient. I'm going to put it down right here. 20, it will be with x to the fourth power, because originally it's x to the fifth. This will be power 1 less than the original. So we will have 20 x to the fourth minus 279 x to the third power plus 1306 x to the second power minus 2014 x, and then plus 84. So that's a quotient. But we still have the remainder, right? And that will be the add-on to it. So plus 121. So we can write this polynomial as a product of x minus 6 and this thing here, but after that we have this addition of 121. Now, if I give you this form and then I ask you, hey, what's p of 6? Well, all we have to do is to plug in 6 into all the x's. And let me tell you, I don't even need to care about whatever this is anymore, because 6 minus 6 is just equal to 0. Right? This is just equal to 0. So 0 times all that is just equal to 0. And then of course at the end, we have that 121. Therefore, p of 6 has to be just this, 121. And then we are done. And this is the beauty behind using the sensitivity division along with the remainder theorem. Hopefully you guys all like this. But of course, if you want to challenge yourself, go ahead and plug in 6 into all the x's and then compute it and verify with me. Don't use a calculator. I trust you. That's it.